Alright, boys and girls, welcome to our last video lesson in Chapter 8, our lesson on probability. Auga? Okay, probability is always a fraction. The formula is, the numerator is the number of favorable outcomes, or in other words, the number of outcomes that work, over the total number of possible outcomes. The denominator is the total possible number of outcomes. So probability is always a fraction somewhere between 0 and 1. In other words, if something has no chance of happening, like when I asked the girl at the prom, but if something has no chance of happening, the probability is 0. And if something is guaranteed to happen, she says no, then the probability is 1. So if there's no chance of something happening, the probability is 0, and if it's perfect, it's guaranteed to happen, the probability is 1. A couple more words you need to know. The experiment or the event is the action when we do something in probability. The outcome is the result of that action. And the sample space is the list of all possible outcomes. So picture, playing a game and there is a number cube, or in other words, a die. One die, two dice. If I roll one die, the experiment or the event is the rolling of that die. Say it lands on a 3. The outcome would be 3. However, my sample space are all the possible outcomes. So it's 1, 2, 3, 4, 5, or 6. 6 possible outcomes in my sample space. The complement of an event is the chances of something not happening. So, for example, let's just get this notation down. Okay, so notation, the vocabulary. If the probability of event A is called P, then the probability of event A not happening, or not A, is Q. Q would be the complement of P. P is always equal to 1 minus Q, or it's easier to sometimes think that the probability of P, something happening, plus its complement Q, P plus Q will always equal 1. So the probability of something happening plus the probability of it not happening will always add up to 1. Okay, in this problem right here, I have 2 bags, each containing a blue and a red marble. Here are my 2 bags, each containing a blue and a red, a blue, a red, and a red. And I have 1 bag containing a red, a green, and a yellow marble. It's right here, a red, a yellow, and a green. If I randomly draw 1 marble from each bag, then find the following probabilities. Now, there are 3 problems here. This can be complicated, so let's actually draw our sample space out. Before I do that, let's think about my total number of possible outcomes. So from our section last section, I know I'm going to have 3 events. I'm pulling 1 marble from each bucket, and I have 2 possible outcomes in the first. I have 2 possible outcomes of drawing a marble from the second, and I have 3 possible outcomes of drawing a marble from the third. 2 times 2 times 3 we know is 12 possible outcomes. Go ahead and stop the tape and list out your 12 possible outcomes. Okay, now we can see, here are my 12 possible outcomes. Like, for example, I could have chosen red, 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 and I was a red from the first, a red from the second, a red from the third. I could have done red, blue, red, a red from the first, a blue from the second, and a red from the third. I could have done blue, red, red, blue, red, red, blue, blue, red, blue, blue, red, etc. I could have done red, blue, yellow, red, blue, yellow, or blue, red, yellow. Notice that this is a different outcome. Blue, red, yellow is different from red, blue, yellow. Okay, but here are my 12 possible outcomes. So now I want to find the probability of drawing exactly 2 red marbles and 1 other marble. So let's look here. My bottom number is going to be 12. There are 12 possible outcomes of drawing 1 marble from each of those buckets. And how many have exactly 2 red and 1 other? Well, there's 2 reds right here and a blue. There's 2 reds right here and a blue. There's 2 reds and a green right here. There's 2 reds and a yellow right here. I think those all the ways I can draw 2 reds and something else. So it's 4 out of 12, which can reduce now to 1/3. And if I look at the next one here, it's drawing a red, a blue, and a yellow marble. Okay, again, I know my total possible outcomes is 12. I need to get a red, a blue, and a yellow in any order. Here's a red, a blue, and a yellow in any order. Here's a blue, a red, and a yellow. That's one of each color in any order. That's the only two ways I can draw a red, a blue, and a yellow. So it's 2 out of 12, or 1 out of 6, if I reduce that. And lastly, I want to draw 3 different colors, 3 different colored marbles. So I know, again, my bottom number is going to be 12. I need 3 different colors. I got a red, a blue, and a green right here. I got a blue, a red, and a green right here. Those are 3 different colors. I got a red, a blue, and a yellow. Those are 3 different colors. I got a blue, a red, and a yellow. Those are 3 different colors. And I'm looking around. I think that's it. I have 4 out of 12. Or a 1 out of 3 chance of getting 3 different colors. Okay, I want to roll 2 dice, 2 number cubes, find the following. I got 3 different little problems here. So again, let's think about what could happen when I roll 2 dice. I have 2 events when I roll 2 dice. So I know I'm going to have 2 events to find my total number of possible outcomes. How many different outcomes are there possible on the first die? Well, we know there's 6, 1, 2, 3, 4, 5, or 6. And I know that there's 6 possible outcomes on the second die. 6 times 6 is 36. There's 36 different ways, so I can roll 2 dice. Go ahead and list them out. Okay, here are all the different ways that you can roll 2 dice. Like, for example, I can roll a double 1. 1 on the first die, 1 on the second die. I can roll a 1 on the first die, a 3 on the second die. Now that's a different outcome than rolling a 3 on the first die and a 1 on the second die. They look similar, but they're actually 2 different outcomes. I could have rolled a 4 on the first die, a 3 on the second die. And again, that's a different outcome from rolling a 3 on the first die and a 4 on the second die. But we can see now there are 36 different ways that I can roll 2 dice. What's the probability of rolling a sum of 7 or 8? Well, I know my bottom number is going to be 36. And let's look at all the different ways that I can roll a sum of 7. Well, 1 plus 6 is 7, 2 plus 5, 3 plus 4, 4 plus 3, 5 plus 2, 6 plus 1. So there's 6 ways of rolling a 7. And same problem. I could also roll an 8. There's 2 and a 6, 3 plus 5 is 8, 4 and 4 is 8, 5 and 3 is 8, 6 and 2 is 8. There's 5 different ways of rolling an 8. So there's 6 ways of rolling a 7, 5 rows of rolling an 8. That's 11 different ways that I can roll a 7 or an 8. So I have 11 out of 36 chances of rolling a 7 or an 8. What's the probability of rolling a sum greater than 8? That means a 9, 10, 11, or a 12. Well, again, I know I have 36 possible ways. All the ways I can roll a 9 are right here. There are 4 of those. There are 3 ways that I can roll a 10. There are 2 ways that I can roll an 11. 5 and 6 and 6 and 5. Remember, those are 2 different ways. And there's only 1 way to roll 12. That's double 6s. So 4 ways to roll a 9, plus 3 ways to roll a 10, 2 ways to roll an 11, 1 way to roll a 12. It looks like I got 10 different ways to roll a sum greater than 8, so 9, 10, 11, or 12. 10 out of 36 can be reduced to 5 out of 18. Make sure you always reduce your probability. What's the probability of rolling doubles? Hey, you know what to do. We got a 36 on the bottom. How many doubles are there? Well, there's double 1s, double 2s, double 3s, double 4s, double 5s, and double 6s. There are 6 different ways that I can roll doubles. 6 out of 36 reduces to 1 out of 6. Okay, picture this. I got a bucket with 5 blue marbles, 3 red, and 2 white. Find the following probabilities. Now, this notation means I'm pulling 3 marbles with replacement from the same bucket in this order. So I want to know what's the probability of pulling 3 marbles with replacement, so that's independent probability of a blue, a red, and then a white in that order. So I'm going to have 3 events, so I'm going to have 3 fractions. First thing I want to know is what's the probability of pulling a blue Well, it's 5 out of 10, because I have 5 blues out of a total 10 number of marbles. I pull that blue one out, I put it back in. Now I want to choose a red one. Well, I have 3 out of 10 chances of getting a red one. Put that red one back in, and now I want to get a white one. I know I have 2 of those, so it's a 2 out of 10 chance of getting a white one. Before I multiply, because I don't have a calc, I'm going to cancel. I'm going to cancel right here. 5 and 10 becomes 1 and 2. 2 and 2 will cancel. It looks like I'm left with up top 1 times 3 times 1, which is 3. And on the bottom I have 1 times 10 times 10, which is 100. I have a 3 out of 100 chance of getting a blue, a red, and a white in that order with replacement. I want to know now what's the probability of doing the same thing, getting a blue, a red, and a white marble in that order, but this time without replacement. In other words, I'm not going to put the marble back in the bucket after I pulled it out. We call this dependent probability. Okay, so I'm going to have 3 events once again. First thing, it starts the same way. I want to get a blue marble. I have a 5 out of 10 chance of getting a blue. Now what happens, I've pulled one of those blues out, so it's gone. Gone. So now what's the chances of getting a red? Well, there's 3 reds, but I have 1 fewer marbles in the bucket now. I only have 9 left. And then, what's the probability? Again, I take that red one away. What's the probability of getting a white one? Well, there's 2 white ones in the bucket, but there's only 8 marbles left in the bucket. Before I multiply, I'm going to cancel. 2 and the 8 can become 1 and 4. 5 and the 10 become 1 and 2. 3 and the 9 become 1 and 3. It looks like up top I got all 1s, 1 times 1 times 1. And on the bottom I got 2 times 3 times 6, which is 24. So I have a 1 out of 24 chance of getting a blue, a red, and a white without replacement. So dependent probability. Okay, you guys try these two. Remember, I got the same bucket with 5 blue, 3 red, and 2 white. The first time I'm pulling three marbles with replacement on the first one. So that's independent probability of a red, and a blue in that order. And then I want to get the probability of getting 3 marbles, a red, and a blue in that order without replacement. This is independent probability. This is dependent probability. So I'll just get you started by reminding you I'm going to have 3 fractions in each. Go ahead and stop the tape and figure these 2 problems out. Okay, for the first one, you should have found pulling 3 marbles with replacement, getting a red is 3 out of 10. 3 out of 10. Getting a second red is still 3 out of 10 because I put the red one back in. And getting a blue one is 5 out of 10. So before I multiply, I'm going to once again cancel. It looks like the only thing I can cancel here is the 5 and the 10. Becomes 1 and 2. So up top I have 3 times 3 times 1, which is 9. And on the bottom I have 10 times 10, which is 100 times 2, 200. So I have a 9 out of 200 chance for the first one. And for the second one now, here I go. I can say I got a 3 out of 10 chance of getting a red one to begin with. But then once I pull that first red one out, there's 1 fewer red ones and 1 fewer marbles in the bucket to choose from on my second one. So I have a 2 out of 9 chance of getting a red one on the second draw. And on the third draw, there's 2 fewer marbles. So I have 8 marbles in the bucket, but I still have 5 blue ones. So therefore, before I multiply, I'm going to, you got it, cancel. So let's cancel the 3 and the 9. 2 times 5 is 10. It looks like I now have all 1s up top, so 1 times 1 times 1 is 1. And on the bottom I have 3 times 8, which is 24. Okay, let's do a couple more problems here, just for the fun of it. Mr. Corbett randomly chose a number from 1 to 15 inclusive. That means it includes 1 and 15. Then he randomly chose a letter from A through P inclusive, so again, including A and P. Find the following. I've listed out, here's my first bucket, all the numbers 1 through 15. Here's my second bucket, all the letters A through P. Okay, so I know, I'm going to put this in right now, in the first bucket, I got 15 numbers I can choose from. And in the second bucket, I got 16 letters I can choose from. So what's the chances of getting an odd number on the first one? Well, there are 1, 2, 3, 4, 5, 6, 7, 8 odd numbers, 1 to 15. And then getting a vowel, there are 1, 2, 3, 4. Even though there are 5 vowels in the alphabet, only 4 of them are A through P. So I have a 4 out of 16 chance of getting a vowel. Before I multiply, you got it. I'm going to cancel. Let's do 4 and the 16 is 1 and 4. I can now do the 4 and the 8. 4 and the 8 become 2 and 1. It looks like when I'm all done, I have a 2 out of 15 chance of getting an odd number and then a vowel. For the second one here, I need a number less than 10 and then a consonant. Well, a number less than 10 would be 1 through 9, so there are 9 numbers. Remember, we had a total possible 15. 9 out of 15 for the first one. And then getting a consonant, well, we knew there were 16 letters. We counted our vowels. There were 12 of them. Not a vowel would be a consonant. It's also called the complement, right? The complement of vowel is not a vowel, which was 12. So now, before I multiply, you got it. I'm going to cancel. 12 and 16 become 3 and 4. And I can cancel a 3 out of the 9 and 15 as well. So that's 3 and 5. It looks like 3 times 3 is 9, and 5 times 4 is 20. Done. All right, you guys try number 14 right now. Give it a go, give it a go, give it a go. Stop the tape. Okay, you should have gotten 7 out of 15 for getting an even number, 1 to 15, and 2 out of 16 for getting an H or a J from A to P. Before I multiply, cancel, 1 and 8. So up top I have 7 times 1, which is 7, and 15 times 8 is 120. How many of you got that? Very good. Okay, and here's our last one, same problem. Find the probability of getting a number bigger than 5, and then the letter P. First 5 people to email me your answer. Email me your answer. We'll get a bonus point on the next test or quiz. Okay, let's do a couple more problems here. Number 66, aerospace engineering. A space vehicle has an independent backup system for one of its communication networks. The probability that either system will function satisfactorily for the duration of a flight is 0.985. So 985 times out of 1,000, the engine will work. Now, the space vehicle has a backup engine with the same probability of working. What is the probability that during a given flight, both systems functions satisfactorily? So again, I'm going to have 2 events. Oop, I need my marker. The first one has a 0.985 chance of working, 0.985. And the second one also has a 0.985 chance of working. They both must work. So therefore, we're going to simply just multiply 0.985 times 0.985, 0.985 times 0.985. Yes, I'm using my calculator. And I got a 0.970225, or approximately 97% chance that both work on any given flight. Okay, we're going to skip B for a moment here. We'll do that one in class, or we'll think about that one in a second. But let's think about C right now. For C, let's figure out what's the probability that both systems fail. Well, if there's a 0.985 chance that they work, the complement would be the fact that they fail. So that's going to be 0.015. So again, I have 2 engines. So for them both to fail, it's a 0.015 chance that the first one fails. And for the second one to also fail, it's 0.015. So I'm going to take my handy dandy little calc here. 0.015 times 0.015 equals 0.000225. So there's a very small chance, 0.000225, chance that they both fail. Okay, now let's go back to B. What's the chances that at least one system works? And that's the whole point. When you have a backup system, if the first one fails, fine, as long as the second one works. Now, there's the hard way to do this, and there's the easy way. Let's just talk about the hard way. The hard way would be to do 3 different problems. Well, you need to figure out the chances that they both work. So, let's think about it this way. Work and work. Get that probability, which we actually we figured out in A. We could also find the probability that the first one works and the second one fails. Get that probability. And then we can figure out the probability that the first one fails, but the second one works. What's that probability? And then add those 3 up, and that would give us the probability that at least one works. However, there's a much simpler way to do this. Let's think about the complement of both systems fail. The complement of both systems fail is that at least one of them works. So if we just think about it this way, we can figure out what's the probability that both systems fail, which we did in C, and then subtract that number from 1. So if you remember, for C we had 1, our answer for C was 0.000225. So basically, if you only need to have one to work, you have a 0.999, I'm doing this in my head here, 775, I think that's right, chance that at least one of them works. Okay, last problem here, and we'll do this one in class as well, but I want you to have it in your notes, just so you can refer back to it if you need to. We're going to talk about you're dealing a card game. It's made up of 108 cards. There are 100 regular cards, 25 red, 25 yellow, 25 blue, and 25 green, and there are 8 wild cards. Yes, this game is Uno, okay? And each player is randomly dealt a 7-card hand. A, what is the probability that a hand will contain exactly 2 wild cards? Which means it's contain two wild cards and 5 regular cards. So let's think now. On the bottom, I need to get I'm dealing 7 from 108 cards. So this is in essence 108 C7. And up top, I need to get 2 wild cards and 5 regular cards. So I need to get 2 of the 8 wild cards, so that's 8C2, and so I multiply, I need to get 5 regular cards from the 100 regular cards, so that's 100C5. And that's your formula for the first. Okay, now for the second problem, I need to get 2 wild cards, 2 red cards, and 3 blue cards. I know, again, my bottom number, now there's going to be a lot of different ways that I can deal 7 cards from 108, but all that is going to be right here, 108 C7. And up top now, I need to get 2 wild cards. So I need to get 2 wild cards. That's going to be, there's 8 wild cards, so that's 8C2. And so I multiply. I need to get 2 red cards. There are 25 red cards, so I need to get 2 from those 25. That's 25C2. And I need to get 3 blue cards. So there's 25 blue cards, and I need to get 3 of them. So that's 25C3. And there is my formula for the second one. That's it, folks. Have a great day, and we shall see you soon.